Hi everyone, I'd just like to do a quick update on the Open Weed Locator and also the OWL3.0 that we've been working on the last few months. So as you might have seen already or built perhaps yourself, this is the 2.0 or the version before that uses the Raspberry Pi 5, all the 4, all the 3B plus, the boards, and then uses a custom OWL driver board on top that manages power and also the 4 outputs. So 1, 2, 3, 3 and 4, and then the enable switches and also the power in. We use the fan, of course, to keep things cool. That is a moving part. And also the IMX296 Raspberry Pi global shutter camera on the front. It's 1.58 megapixels. And this all sits on a tray, and that then goes into a 3D printed or aluminium or whatever enclosure you feel like making. That's the current status of the project. And so then over the course of the last 6 months, I guess, 8 months, we've been working on turning this 3D printed version into one that's more robust. So this is the OWL3.0, and it uses a custom CNC machined aluminium enclosure now, and also a heatsink backplate. It is effectively the same if you include all the features of this original one. So it's still a Raspberry Pi 5, but instead of using the board, we now use the CM5. So the same processor, just on a much more compact board, without any of the unnecessary features that we don't need. Plus, we can now integrate the Hailo 826 TOPS chip here, so we can run custom detection models for more powerful green-on-green performance. We also have a whole lot more features as well, so things like NB-IoT, so connectivity support. It won't be entirely implemented. It wasn't entirely certified as well because we wanted to keep things more simple, and that it ties you to using SIM cards. But the board does support it because we use the Nordic Semiconductor NRF9151 chip that also includes GPS now. So all of these have GPS connected, and of course Wi-Fi and Bluetooth that come along with the compute module when you can get the ones that have the Wi-Fi and Bluetooth. On the other side of it, so the face, you still have the same sensor, the IMX296, but it's in a smaller form factor to fit inside a much smaller case, but still the same sensor. Here you have your outputs, so GPS only currently on this one, but you can also drill through here to put in your NB-IoT antenna and also the Wi-Fi antenna. We also have Ethernet connection, but through a M12 IP rated industrial connector. And this is up to gigabit speeds through here, so you can stream potentially a movie across your boom. And we still have the 4 outputs, but now we are moving to the Deutsch plug 12-pin connectors, and these are much more industry standard in this space, more robust, again much more capable of being replaced on farm, and require less equipment, I guess, than some of the ones we've used previously. So that's the enclosure itself, and you can see the backside of it. The camera sits underneath this board, and you can see this is when it's in its enclosure. It does have these M6 holes on the side to mount it, and we do also have a shield that we are producing, so you can mount these to various pieces of equipment. The board itself, this is, you can see when it's outside of the enclosure, this is where the Raspberry Pi CM5 would sit, this is where the Hailo would sit. And then you have your other output management. So these are your 4 outputs there. Then you have power management on this side, and also the large connectors that are soldered to the board. But you can see that's where the board sits like itself. Eventually, we will produce a 3D printed version of this CNC enclosure that people can make themselves and then use this board in as they see fit. But we'll, of course, be publishing, as usual, everything open source. Now with the connectivity, so with the Ethernet, just as we do currently with the controller, we can connect these via an industrial Ethernet switch. So something like this, where you take all of these and connect them to the switch, and connect the switch then to a router, such as a Teltonica router we typically use, and then to a controller, so you can manage all your hours on your spray boom remotely and see how they perform. So that's the current status of the project. I'll keep things updated on the community page, and feel free to get in touch if you have any questions. But thanks as always for following along, and hoping to get these out into the world very soon.